All right, so we should be good to go. Welcome everyone to, I know this is a little bit out of character for us doing this on a Sunday, but to the Fossils live stream. This is an informative event hosted by the Science Olympiad live streaming team. And my name is Cruz. I am a test writer and a previous competitor from Fresno, California. I competed for Edison High School. I was one of the competitors for Fossils and often competed at the state level and the regional level in that event. And now I'm currently a freshman at the Massachusetts Institute of Technology. I will be writing the fossils exam for that event. So you may see me there as your event supervisor, as well as running this event and supervising and writing for fossils, as well as a few other events at multiple other competitions across the country. So definitely a familiar face, and I hope that I will be able to help you all here tonight in talking about fossils, not necessarily about the event rules and the speculation, because I know that that's a lot of work that you've done already, but rather I hope to spend a little bit of time talking about the rules, talking about semantics and things that you probably would already know, tips and tricks, and then spend the second half of my live stream talking about how myself and other test writers for this competition will most likely adapt to the conditions of COVID, how the test questions are going to change, and how that specifically pertains to fossils and the kinds of advanced questions that we might ask. So I'm going to go ahead and get started talking about fossils. So overall, the most, I guess, the most identifiable portion of this competition is the identification portion. You know, you have a list of, now at this point, I think it's over 200 different samples. So you have a lot of different critters and creatures, as well as plants and animals that you will need to identify. And so what our team usually recommends, and what most of you probably already practice, is the idea of having a binder that you can use for any information. You can have sections, whether you have 2 per page or 4 per page or 1 per page, to have sections and tabs for each animal or creature or fossil or whatever else you want to call them. You could use that binder to then be able to access information based on what you identify. So the best thing I can recommend is more or less what anyone would say, is to have smaller binders. The smaller the better, because the easier it is to find information in a smaller binder. Overall, to definitely have as much information as possible from every entity that you can most likely use actually from from actual sample tests that you might take, or from competitions. Usually for most invitational tournaments, as well as practice tests, you'll be able to get your results back, see what you got wrong, and possibly you'll have questions, for example, a defining feature or something that is looped into a specific creature that you may need to identify. One prominent example I remember from when I was competing was talking about the Nidia, and they asked us, oh, what was the scientist who identified this? Why is it named Nidia? And specifically, what institution did this person teach at? So if I remember correctly, it was named after a professor whose last name was Knight. He was, as you might imagine, he was an archaeologist and paleontologist. And he was, if I remember correctly, I could be wrong. It's been a while since I competed in this event, but he was a professor at the University of Wisconsin, I believe. So things like that are very niche, but very legitimate things that someone can ask you, and definitely something that you'll see in this competition season, ultimately, because we need to A, step up the difficulty of questions, and B, ask you questions that require a lot more critical thinking rather than just knowing an answer as well, because it's a lot easier to just look stuff up on the internet if you don't have to do any critical thinking. So one of the things I'd also recommend is that when you have an animal, or when you have, I'm just going to say animal because most of the issues that I have with animals, plants are a bit easier to work with, as well as protozoans. So when it comes to an animal, down here, you have a whale vertebra, and you also have, in the bottom right, you have a tooth of a basilosaurus. And both of these ultimately could be given to you as samples. Excuse me. Oh boy, had a long day. Shouldn't have had that last root beer earlier. But both of these are viable samples that they can give you from a basilosaurus. But meanwhile, you could also see this backbone on more or less any mammal. That's very important to see. Basilosaurus is a whale, but you could also see it even in a mosasaur. I've seen, obviously not of that size, but a mosasaur spine will more or less take the same shape as that of a whale. Obviously, there are distinct characteristics that you can memorize, but most of the time, what you're going to see is a lot of these samples sort of grapple together, and you can sort of identify what one might be off of the other. But it's also important to remember that if that is not the case, you need to make sure that you identify all possible parts of an animal that you might need to identify. Usually with dinosaurs, that's going to be teeth. If it's not going to be teeth, it's going to be usually bones that come from the leg. Usually, sometimes that's going to be a femur for lizard hip dinosaurs. And almost all the time when it comes to rarer samples, you're going to get images. So make sure to also build up a good repository of images that you could collect. Okay, so next up, we're going to be talking about specifically binders. So when it comes to building a binder, what do you need? Again, a lot of this is going to be things that you've already incorporated, but hopefully I can introduce one or two things that you may not have thought of. So generally, this is a format that I pulled from the binder that I had at Edison. This is still a binder Edison used to compete. So I apologize to Edison if you're not placed first today at any events because the fact that I shared this information. But ultimately, usually you want to have an image or a compilation of images. Preferably, sometimes you might want to have diagrams that you can use to identify various parts of an organism. Now you can have all of this fundamental taxonomical information. I know that at the state regional levels in Northern California, it is very important to know taxonomy of certain animals and critters. So it is also very important to identify a variety of things. For example, who discovered it, which is not on this piece of paper, but is something that I wrote in from doing research after having printed this out. You can also talk about its distribution. Its geographic distribution is very important as well as its distribution throughout time. Not sure, it's written down there, but previously what I had done is actually in this academic year, we had implemented a diagram that showed a highlighted section of the geologic time scale in which this animal existed and was alive. So that's also very important, which we'll talk about later when we get to a little bit of a discussion about index fossils, and as well as just any general information in this description. So really this description is used for anything that does not fall into any category that you might have. Ultimately, things like I mentioned earlier, like the NIDI identification, talking about that very niche story, things that are very unique to an animal that you might need to know. Another thing that I might want to add, another example, would be talking about Titanus walleri, or the terror bird. And one thing that is important to know about the terror bird that may not be mentioned in all of these categories, it's not encompassed in it, is that there has never been a skull of that creature discovered. And despite the fact that when you get a sample or an image, almost always they will depict the skull. They will depict a talon or a skull. And so it's very important to know that despite that being a very popular part of a paleontological circle, you might not necessarily have an actual concrete sample. You might not have evidence that the bird actually looked like that. And so it's important to know that Titanus walleri did not, in fact, have a skull discovered. This is something that we inferred based on a variety of other things. For example, things that were found on animals of that time. We could tell how it hunted, so we could tell that it had a beak, a particularly large beak, as well as the shape of many of its limbs and its skull structure, its bone structure, that were used to support a relatively large head. So based on inferences that we make on other body parts, we can identify that it had a head that was of some nature, the shape that you'll see in popular culture today. But again, that's just one of those things that doesn't really fit into any of the categories that we discussed in building binders. And I already said, sort based on the list. You always want to organize stuff taxonomically. Some people may have completely different ways of doing this. Sometimes people might want to do this alphabetically. Personally, I'd find that a little bit weird. Definitely would take some time getting used to. Overall, sort it however you like. This is what I recommend. But again, it's best that you know your binder and use it as little as possible, simply because you want to have a binder that's easily navigable. You want to have a partner or a group of partners that is very capable of answering questions without the binder and only turning to binder when needing to identify crucial information. All right, so we're going to go ahead and go to the next section. So now I'm going to talk about a few things that are listed in the rule sheet that are important and that I think might be a bit more pertinent now that we're talking about things that are more abstract, as opposed to talking about identification. Because one of the things this year that we will still incorporate but want to stray away from in questioning is things when it comes to identification. So identification is something that you can't really beat around when it comes to online testing. It's very easy to just be able to reverse doctor a photo. It is very easy to just be able to look stuff up on the internet for identification. Even especially if we gave you a piece of information, we could ask you who discovered this dinosaur, or maybe you would discover, you see the claw of an Allosaurus. You say that's an Allosaurus. Then we say, who discovered the Allosaurus? Where is the Allosaurus located? We could have things like, what period was the Allosaurus most prominent in? All of those things could easily be, you could easily Google those things, just literally copy and paste that question into your search bar, enter it, and I'm sure you could say, oh, the Allosaurus was prominent during the Jurassic period, around 160 to 145 million years ago. It's very easy to reverse doctor those answers. So we want to stray away from them as much as possible. Again, we won't entirely abandon them, but these are some things that are lower on your list that personally I didn't worry about too much when I was especially in Division B or in my early years of high school, because almost all of the questions were very, very identification heavy. So we're going to start straying away from that. We're going to ask you to think a bit more and ask you more multi-part questions where you will build off of the answer in previous questions that you can only really get to unless you have the necessary skills to do so. So we're going to go ahead and get into the extinction events. These are all five very, first of all, these are all five very important events to know that are mentioned explicitly on your list. And it is important to know, A, when they happened, B, what percentage of life they might have wiped out. Most of them, it's 80% or higher. And then why they might have happened. And the reason that this is not necessarily an identification bit is because talking about why they might have happened, it requires a bit more critical thinking. So sure, you could probably search up reasons why. For example, for almost all of these, you could literally say, oh, I think climate change. Climate change is a very easy answer to why most of any extinction event happened. You could talk about climate change. But ultimately, there are things like the Triassic extinction. We don't actually know. Oh, why is this loading? So why did this happen? We actually don't know why that Triassic extinction happened. Ultimately, we can talk about a lot of things. So the Ordovician extinction is probably linked to climate change, as well as to tectonic plate shifting, as well as to the temperature overall of the oceans changing, which again is linked to climate change. But the Triassic extinction is a lot of speculation. We have a lot of evidence for why the Permian extinction happened. It's due to the amount of oxygen in the atmosphere changing. It's due to some volcanic activity, etc. But we don't really have that much evidence for the Triassic period. And so if you were to reverse Google that, you could come up with most likely a lot of the answers of speculation that we have. So this might have also been due to change in O2 levels. This might have also been due to a tectonic plate shifting. This might have been due to volcanic activity, to climate change, the very popular explanation. But again, we don't really know why this happened. And that's not something you can really get from a good reverse image search. And then finally, the extinction that is not pictured on here is the Cretaceous Tertiary extinction, KT extinction, or the Cretaceous extinction, which is probably the most famous extinction of all time. And again, I'll give you another example of a question that we could ask that would necessarily require a lot of critical thinking. We could ask you, what was the extinction that caused the dinosaur to be wiped out? That could probably be very easily researched. But then we could also get into more critical thinking ideas. So we could talk about, okay, as you know, that the main explanation for the extinction of the dinosaurs during the KT extinction was an asteroid strike on the Earth. as well as the pollution of the atmosphere as a result of that asteroid strike. This is evident by remnants of an element that we found in this particular crater in Mexico. Name the crater and then talk about the element that we found that indicated the presence of a meteor. Now that it would require a lot more reverse searching and a lot more critical thinking based on what you might have. So the answer to that would be, we found it in the Chicxulub crater in Mexico. And we also found traces of iodine in the crater that could indicate that there was most likely an asteroid strike there, a massive asteroid strike that, that definitely led to the extinction of the dinosaurs. And then furthermore, we could talk about what possible side effects of this impact could considerably have led to such a widespread extinction event. Is this the only? So we could ask you to make inferences based on what would happen after an asteroid strike. So again, that requires a lot more critical thinking. And then finally, we could also show you graphs of CO2 levels changing. So we could say, based on this graph, say that this event happened. When could you say that X amount of life might have gone extinct? At what point? So we could ask you to interpret data that we provide as well. So again, these are just all forms of modification of our tests that we might carry out based on the new conditions that we have for COVID and to prevent cheating. Not that most of you would cheat. Only these sorts of changes that are going to be implemented for these tests coming up. All right. So now here's another major group of things that you might need to just memorize are the major deposition sites. So major deposition sites, as listed there, contain different plants and animals, usually from different points in geologic time. At the time, it's good to know what sorts of animals would be contained in this deposit, in these Lagerstätten. So, for example, Beecher's trilobite bed may have a lot of later end trilobites. However, Burgess Shale might have a lot of more ancient trilobites like Rotida family trilobites, order trilobites. So Amazing Creek during the Carboniferous might see a lot of animals. So you can see a annularia here would mostly be present in Amazing Creek. And Ghost Ranch is a very awesome example because Ghost Ranch would most likely have a large deposit of things like Trudon and other animals that were present during the Triassic period. Again, it might also be very important to know A, the major mode of preservation for a lot of these animals, as well as B, where these places even are. So Ghost Ranch is, I believe, in New Mexico or Texas in the United States. Beecher's trilobite bed also has a lot of these samples that are preserved via pyritization. So it's important to know your modes of preservation as well and apply them to these sorts of, to apply them to these locations. Okay, so now you have more major deposition sites. You have 8 total. La Brea tar pits, which I have had the privilege to visit in California, would definitely recommend it as a location to visit. We have the Green River Formation, so Hofen Limestone, Nixian Formation. So as you can see, these all carry us kind of meander us through geologic time, closer and closer to the present, and all contain a wide variety of flora and fauna from those periods. So Solnhofen limestone, probably the most fascinating, contains a lot of soft bodies. So as you can see here in this image, this is going to be a jellyfish, as you know, is one of the things on your list. So it's going to be important to know that if they ask you a question talking about, hey, you identify this creature, which site would you most likely be able to identify this creature at? And then you'd say, well, Solnhofen limestone is most likely the Lagerstätten deposit that we will be able to identify this creature at. All right. So that's the end of the presentation part. Now, what I'm going to go ahead and do is, if you could bear with me for a second, I am going to transition to sharing my screen on a different device so we can go over some question examples, particularly 2 question examples that I want to talk about so that you can get, again, a better idea of what sorts of discussions we're going to have. I'm going to stop my share here. I'm going to go ahead and share my mobile device. All right. So you're going to see me looking down a bit. That's simply because I'm looking from my computer to my iPad. No worries there. So we're going to switch over here. All right. So once this goes ahead and loads, great. So this is a discussion about what sorts of questions we might have that would require a more high-level interpretation. So these are just two examples that I've sort of bracketed up based on my experience and based on what I am thinking of or have already written for events that are ongoing for the upcoming competition season, or actually, I guess for the active competition season. I've already think of it. So a very prominent example that I want to talk about that you've all seen before on tests is relative dating. So relative and not in the incestuous term whatsoever. That's a good archaeology joke. We're talking about relative dating in terms of being able to say invoke the law of superposition, which is the idea that if you have a layer on top of another, as you might all know, this central layer is definitively newer than this older layer below, simply because it's kind of impossible to have a layer and then have another layer magically, by violation of gravity, come in here and then fill it up. That just seems illogical. So most of the time, you have any layer that is superseding another is going to be younger than the layer it supersedes. So that is the law of superposition. So we can invoke the law of superposition to say that if I have samples in said layers, and we can date either the material in these layers or samples in those layers, we can go ahead and say that this sample B is younger than this sample and older than these samples. And that's already probably one or two questions worth of information there that we could ask you. So we'd probably start off asking, so define the law of superposition. Go ahead and give us your own definition of it. That's considered like probably a mediocre type of question we might ask in terms of both difficulty and an ability to avoid cheating. But another advanced question might be, how would you apply the law of superposition to the idea of relative dating? Now, this definitely would be something that you can't necessarily Google. This comes from mere experience, practice, and diligence in this event. So definitely a lot more difficult than simply just a reverse search. So we can invoke the law of superposition here to say that we know that sample B is going to be somewhat in between the ages of these three samples. Right? So younger than these and older than these. So this might look like a pizza, which it probably is. I should probably improve my art skills, but this is actually a mosasaurus tooth. And then given that my mosasaurus drawing wasn't very accurate, we have here a belemnite. And then down here, this probably does not look like a good drawing. Again, I'm not in this event necessarily for my drawing skills, but rather for my enthusiasm for archaeology and paleontology. But this is an Allosaurus claw. So for those of you who are familiar, you can already probably tell right off the bat that these two groups are good examples of index fossils. And so we'll talk about what an index fossil means later. Actually, this one not so much, but these definitely are. So these are good examples of index fossils. And so we can use that to identify the age of this sample in here. And we can do that through relative dating. So let's say I have the Cretaceous, actually, let's say I have beyond the Cretaceous, I'm gonna just call this T for tertiary. I have the Cretaceous, the Jurassic, I have the Triassic, and then I have the, and then I have, before the Triassic, so the Permian. All right, so we have all of these periods of geologic time labeled out here. So what can I do with this? Well, I'm going to go ahead and figure out, well, how old is this mosasaur? What period in geologic time did the mosasaurs live in? And we find that they live usually in the very, very late Cretaceous little bit into the tertiary area here, right after the extinction. So we know that they're here. Specifically, this is around, 82 to 66 million years ago. So actually, it's a little before. So we know that this is about 65 million years ago. So we know that we have this area here that's covered by the mosasaurs, and the belemnite is also around the same range. Belemnites appeared around 84 million years ago. So we also have this here. So we have the dates of layer A, and we also could determine the layers, the ages of this layer down here. I'll use this color for the Allosaurus claw. So if you know Allosaurus, you know that Allosaurus predominantly existed during the late Jurassic, but if you don't, you know that late Jurassic is around 160 to 145 million years ago. It's going to be right about here. The Allosaurus is living. So what does this tell us? Well, since we've been able to invoke the law of superposition here, we know that whatever age this is older than this, and whatever age this is younger than this. So we can safely say that period in geologic time that is represented by this animal here, well, assuming it's an animal or sample, is around here, around here. So it's a very narrow strip of the early to mid Cretaceous period. So it didn't exist for very long, right here. And so that would be an answer you could provide. So you could say, okay, we know for a fact that this animal existed between, I can say about 145 to 84 million years ago. Cool. So that is a great example of what type of question we could ask you. We could ask you to draw something like this out. But again, you might just be able to search behind to reverse search the ages of the sample. So if you know this is a mosasaur, you could hit search age of mosasaur, probably something you should have in your binder. Allosaurus is the same. So another question we might ask is, what sample on your list could this be? What sample is it? Oh yeah, we'll talk about it in a second. And so obviously, I haven't prepared a particular good example of what this might be. This might actually be another belemnite, because as we know, belemnites existed before the mosasaurs, and it's quite possible that belemnites formed, that you just have a belemnite that is older than that belemnite. That's entirely possible. That's something you could suggest. You could probably suggest most of any creature that lived in the Cretaceous period. You could suggest, for example, a tyrannosaur, etc. Or maybe if you're given an image of that sample, you might have some sort of a bone. So maybe you don't identify what dinosaur that bone is from, but based on the observation that you've done with relative dating, you could then narrow that down to what sort of dinosaur that might be. So all of these are viable options for how you answer a question like that, but none of them could obviously be achieved with a reverse image search based on the constraint that you have with your list. So those are all good questions that we might ask. And finally, we might ask, is this a good index fossil? And again, now you'd have to be able to ask yourself the question, well, what are the good features of an index fossil? So an index fossil has three main defining characteristics. So the first one is that it is it has a very diverse range of geographic distributions, very wide geographic distribution. So Mosasaurus here is very widely distributed. You can find it in the United States. Very prominent samples have been found in Morocco, as well as even in Thailand and other parts of Asia. So a very, very diversely geographically, distributed animal. So definitely Mosasaurus meets that description. But again, we're talking about sample B. So could you prove that this sample is distributed across a vast geographic range? Well, you could either do that based on the sample that you identify, or if you don't identify a sample, well, that might be provided the question. You might say is based on the fact that this creature is seen across a wide range of regions. We might say that it's found on 4 to 5 different continents. You might be able to determine, okay, this is a good index fossil. Well, what's another good feature of an index fossil? An index fossil is, this is probably most characteristic to the pollen that you just did. An index fossil or a trace fossil is very, very good about being alive during a very narrow period in geologic time. So, for example, I think the Nautilus would be a terrible example of an index fossil simply because it has existed for a very long period of time. You're talking that it's running up all the way through the existence. It can run all the way up through multiple periods of time, and exist to this day. Ammonites are very similar, probably existed for a very long period of time. So overall, those are not good index fossils because they existed for a very, very wide range of time. So you need something that is very widely geographically distributed and very narrowly distributed in terms of geologic time. And then finally, you need something that is easily identifiable. So overall, that's probably the most difficult thing that you could, put your finger on. What is and is not easily identifiable. Maybe something that I could not easily identify or another competitor could easily identify might be a far more easily identifiable to a scientist in a lab that can analyze possibly the chemical composition of a sample to determine what type of creature it is, something of that nature. So most likely that's not something that we would, ask you about, rather something that we might give to you. Good. So finally, it might be a good idea to have a list of what are and are not good index fossils. That's very important. Have a list of index fossils as well as fossils that may be important for one reason or another. For example, a Glossopteris, I think, is a fantastic sample to talk about in this range because it has a very wide geographic distribution and is used to legitimize the theory of continental drift. So it was very, very important in that discovery. And so it should be noted for that purpose. And you might have a list of things like, of things that are important in that realm. But you might also have a list even of state fossils, that might also be able to tell you where in the United States, given that this is a US-based competition, certain samples are found, as well as where they're most prominent. So, various trilobites are noted to be the state fossils of different states. And that's also important to ask. All right. So we're going to ask about a second type of question, is not necessarily modes of preservation, but how accurate certain modes of preservation, as well as multiple alternative modes of measuring age. So we're talking about things that aren't relative dating and aren't radiometric dating. So things like carbon dating, uranium dating, aluminum dating, those things. So other than that, what's going to be important in telling us how old something is and how accurate is that? So for example, something that's very useful in that are ice cores. How far back could ice cores tell us something is? And ice cores are almost always used to validate carbon dating claims, as well as tree rings are also used to validate carbon dating claims. But something we might ask is, okay, here is a sample that was measured using, that was dated using ice cores. How accurate would you say that the measurement of age for this sample is very accurate? So for example, if we say, here is a mosasaurus tooth, and it was dated using the fact that it was found in or near an ice core, how old might this be based on the ice core? And if this reading is accurate, is this reading accurate? And so mosasaurus, we know, lived probably about 65, 66 million years ago. Well, how old can ice cores usually measure in terms of geologic time? And definitely not that far. You're looking at ice cores measuring maybe 800,000 years ago, maybe if you're really pushing it, 1,000,000 years. So something at 65 million years old is not you can't date that with an ice core. And much less, let's say you had a Smilodon tooth, right? So you have a Smilodon tooth, not sure why you would date it with tree rings, but let's say you do. How accurate would that reading be? Not very accurate at all. Tree rings, usually the oldest trees in the world right now, are about maybe 5,000 years old, which is definitely way more old than we are. But again, it's nowhere near as old as a Smilodon might be. Smilodon went extinct about 33 to 30,000 years ago, which is far older than any of these trees. So not a good sample. And finally, we have things like amber/copalization as a form of preservation. You might date at this point, this is just a mode of preservation. Almost never are you going to be asked about how old something is based on its mode of preservation. as well as things like honey course, I think was something that someone mentioned to me earlier. Just thought I'd mention it in the discussion here. Not sure if anyone is thinking about asking questions in this department. I highly doubt it. But another great example that I failed to draw in, and I'll go ahead and draw it before my iPad dies, is coral. Coral is another great example that can be used to validate carbon dating. It usually goes about as far back as ice cores in terms of 800,000 years ago, if not longer. You have corals that can also be used to validate how old something is. It's a very bad coral. I meant to draw it somewhat like this. Again, in case you haven't noticed, I did not get here based on my art skills. All right, so that being said, does anyone have any questions based on what we're looking at, the changes that we're looking at for this coming year, or pretty much anything when it comes to fossils? I apologize for my inability to speak tonight. I was supposed to have a partner, but she declined to show. That's a habit with the Science Olympiad of mine. But yeah, I'm open to answering any questions, as well as anyone who could contact us through the Science Olympiad live streams, Instagram page, as well as the Facebook page.